Welcome, viewers, to The Space Weather. I'm your host, Dan, a.k.a. Smash-O-Mash, at the Smash News Network, least busted name in news. And if you're looking for less sunspots, you've come to the wrong place. If sunspots make you scared or mad, and if you don't like coronal mass ejections and other exciting stuff happening in the realm of space weather, well, then, sorry, didn't mean to disappoint. If you're looking for the top solar imagery in the universe, the known universe at least, you've come to the right place. We've got a significant sunspot group setting here, likelihood of large solar flares reaching critical mass. You could say practically 100%. We've also got new sunspots having risen and formed in the northeast. So exciting stuff going on there. Again, if you're adverse to sunspots, coronal mass ejections, and other exciting solar activity, then sorry about that. But if you like those sorts of things, you are definitely in the correct location. So we'll also go around the horn here. We're looking at two wavelengths from SDO. That's 131 plus 171 angstroms. That's a magnetically complex group down there also. It's capable of producing large flares, even though it's not a super large sunspot. We've also got another active region rising here, and likelihood of coronal mass ejections, you could say, is, well, 100%. So we learned that we could forecast coronal mass ejections a couple years ago, and it didn't do anything for our channel coverage, so we just simply stopped doing it. This filament right here is about to break loose. So there is a pretty wild active region right behind it also. That filament, we've named it the Brian Keating filament. So you can follow us on Twitter to, quote, name that filament and, quote, use the hashtag name that filament. And you, too, can name filaments after living people. There are certainly lots of them. Here's a close-up of these new sunspot groups in the northeast. We expect to see an uptick in the radio flux, sunspot number, etc., as there's one named group that's now up and running, and it's this group right here. It doesn't have a name yet. It'll get one today. Let's take a look at the full disk view in SDO intensitygram. Here's your gray SDO intensitygram. Again, likelihood of major solar flares very high as a result of this region. And that's Alfred Hitchcock, by the way. And likelihood of flares rising in this region also. Also, likelihood of flares down here as an active group is rising. So also, we'll explain why there's going to be a coronal mass ejection soon. Will it be earthly directed? Well, it's way too early to tell that. We can't forecast the trajectory of them before they eject. But we learned years ago that we can forecast CMEs. Yeah, coronal mass ejections. They can be forecast. It's not that big of a deal. And anyway, there's your SDO colorized magnetogram. We'll talk about coronal mass ejection forecasting a little bit later in the video. First, let's take a look at Croissant Earth. Yeah, the Croissant Earth. There's a little slice of it. That's Cotopaxi. Some splentacular imagery there of the Cotopaxi volcano. Let's see what else is erupting. Shivaluch, producing a 13,000-foot ash plume as it explodes. Flight level 130 over Kamchatka. Abiko, flight level 120 over Paramushir Island. Sakurajima exploded as well. About an hour-long eruption there, 5,000-foot ash plume generated. Suwanosejima fertilized the area downwind with a 4,000-foot cone of volcanic ash as it exploded. Popocatépetl has dispersed its ash, so Popocatépetl has taken a little rest there. Santiaguido exploding, flight level 140 over Guatemala, flight level 160 over Guatemala from Fuego. In Colombia, you've got Nevado de Ruiz exploding. That seems like a good one for your bucket list. Flight level 190 over Nevado de Ruiz. It's a 19,000-foot ash plume. 19,000-foot ash plume from Sangay. 14,000-foot ash plume from Revenador as it explodes. And there's Cotopaxi. It did get as large as a 25,000-foot ash plume there. Currently showing as 21,000-foot ash plume. Flight level 210. Flight level 240 over Sabancaya in Peru. Please do not pull Volta Caldera. Here's the seismicity of planet Earth for the past 90 days. We've had a big uptick in earthquakes around the Pacific Rim, so this is another warning here. One or more of these earthquakes could be a foreshock, so that is definitely a legit earthquake warning. That little triangle right there, as we know regularly, we cover foreshocks on the channel. So when you see a big earthquake, don't assume it's the final earthquake. Have an idea of which buildings might collapse in your area and so on. Have a plan if facades start to fall, maybe don't be under those. Anyway, some plan is better than no plan, right? Here are the earthquakes over a 5 magnitude. We've got a number of them, like this 5.1 in the South Sandwich Islands. And then an hour and 5 minutes later, this 5.0 near Japan. Later last night, Universal Time at 1928, we had a 5.4 near the Mariana Islands. And then 1 minute later, a 5.0 at Russia. So practically simultaneous quakes there. Thousands of miles apart in the West Pacific. Indonesia, Sumatra, Indonesia, had a 5.0 at 23:05 last night. Papua New Guinea had a 5.0 at 2:01 this morning. Mexico had a 5.7. That was at significant depth there, 87.7 kilometers. That was at 4:40 this morning. South Georgia Island had a 5.2. That's by the South Sandwich Islands. And Russia had a 5.2 at 6:14 this morning. So big uptick there, especially in the Western Pacific. Also a significant quake in Mexico and some around the South Atlantic/Southern Ocean boundary. Let's get back to space. There's plenty of action going on there. And yeah, that's what we started out with. Fantastic composite wavelengths there from SDO. Just good stuff. And take a moment to press like and subscribe if you enjoy the content. Tell your friends and foes about us. We're not convinced that YouTube recommends the Smash News Network, least busted name in news. And thanks for leaving comments, Tinman1057 and Mr. Bordages. Yes, press like, subscribe, share, etc. Tell your friends and foes about us. Visit the links below the video. Congratulations on new viewers. Congratulations to viewers on finding the channel. If you want to support the content, consider becoming a member of the Smash Team at smashomash.com/Smash Team. We launched it back in October 2021. If you want to learn about a plausible mechanism to explain the solar sunspot cycles, well, it'll only cost you $10, okay? You can get a smashomash.com email address if you like. Most first names still not taken. If you want to be Steve or Pierre at smashomash.com, perhaps you'd like to be R2D2 at smashomash.com because you're a Star Wars nerd, not a Star Trek nerd. I don't know, whatever. Anyway, the point is a gold membership gets you an email address if you like. A gold annual paid-up subscription gets you complimentary merch. It's almost like getting 4 months of a gold membership free. And let's get back to our space weather coverage. As the 10.7 centimeter radio flux now is up to 166, is it? 162, it looks like. There we go, 162 for the 10.7 centimeter radio flux. There's the 1-year chart from solon.info. So, yeah, the radio flux, if you're a new viewer, you may not be aware that the radio flux is directly proportional to the sunspot number. So we've seen a big variation here in the AP index. So you see that blue spike down there at the bottom? That's the interplanetary magnetic field, the Potsdam AP index. And, yeah, we're expecting an uptick in all of this once again. As again, we've got a number of sunspots here showing up in the northeast and another one about to rise in the southeast. So here's your space weather enthusiast dashboard, and NOAA is not forecasting anything in terms of space weather storms here. Pretty calm conditions here at the moment. That's the forecast for the next 3 days. And here is your planetary K index. That's an average of Earth's geomagnetic field strength. Current conditions are KP 2.33 for the planetary K index. Let's take a look at Earth's magnetic moment from space for the past 4 hours as modeled by the University of Michigan Geospace Model V2.0, the space weather modeling framework. Looks like we've had some recent variations here in the past 4 hours in the solar wind. Again, things geomagnetically calm here. We still do have an elevated solar wind, but it's not as elevated as it was, as it reached nearly 900 kilometers per second. So here's the past 4 hours. This is Earth's magnetic moment from the ground, geospace ground magnetic perturbations. And of course, if Earth's poles were actually going to flip, we would see all kinds of evidence on the imagery, which we don't. Next, we'll take a look at the real-time solar wind information. So here at Lagrangian point 1, that is where your ACE and Discover spacecraft are measuring the solar wind, and the current conditions are, this time, once again, like yesterday, only the Discover. So coming down below 500 kilometers per second for the solar wind speed here, solar wind density just over 10 protons per cubic centimeter. The rest of that is fairly unremarkable. Let's take a look at more magnetic data. So here are the GOES magnetometers measurements from their geosynchronous near equatorial orbits. And here is our top view ecliptic plane field plot. Now, this is super valuable information as it shows us the sector boundary crossings, which are those areas there where you see the green turning to red and so on. That's the polarity of the heliospheric current sheet. And what's interesting here is actually we've got a bunch of South Pole magnetism hanging out here kind of near the North Polar region, but we've still got a bunch of North Pole magnetism hanging out there also. So that needs to evacuate the North Heliographic Pole before you can say you're at solar maximum. So a word to the wise. You're not at solar maximum. Now that I've gotten that out of my system, here's our line of sight field plot. And this depicts the sun's B field in blue. Polar fields in red and green, obviously. And here is our line of sight coronal hole plot and a bunch of South Pole oriented coronal holes here in the earthly portion of the solar disk. Welcome to the South Magnetic Pole. You're currently in the solar system's South Magnetic Pole. And there's a great view of it in SDO 211 angstroms. Now, the great thing about 211 angstroms is not just the fact that it shows coronal holes. This one is major, by the way. It's going to cause significant solar wind. You can expect maybe 700 plus kilometers per second from that one. And another great thing about 211 angstroms is it shows the extended corona. Of course, it actually goes outside of the field of view of the SDO over here on the left. You can see it's almost showing most of that data there. That's ionized iron, by the way, and we're going to get the sunspots here in just a moment. We've got one more named group here. So this group here is magnetically complex. It's certainly beta gamma class by now. We'll show you high-res imagery of that toward the end of the video. And the most likely place to see a really large solar flare is from sunspot 3234 and the surrounding area. There also is a very, very high likelihood of a major flare down here. So we are expecting, again, that's not a flare prediction. That is a coronal mass ejection prediction, as those things are often concurrent events. We don't say the one causes the other one, though, as causality is very important in the realm of physics. And there are chicken-egg arguments. In other words, you don't want to suggest that the egg laid the chicken, if that makes sense. Anyway, here are sunspots. We've added 171 angstroms here to show all those active regions. So the eastern limb there, featuring quite a bit of uptick in solar activity there. So right on cue, the sun has responded with people's forecasts being incorrect about the radio flux not getting over 170 and all these sorts of things. I mean, almost instantaneously. It's almost like their consciousness is controlling the sun. Just kidding, folks. And by the way, planetary motions do not control solar activity. So can you just get that out of your system, please? Planetary motions do not control solar activity. So here we've zoomed in and we've added 94 angstroms. And I assume we'll get a whole series of comments about that. That's fine. Good luck proving that extraordinary claim with some extraordinary evidence. All these videos, by the way, are the past 24 hours. So on the daily space weather videos, that's one of the great luxuries we have, is showing these 24-hour videos daily. There you can see a bunch of new sunspots rising and forming in the eastern limb there. We do have this equatorial sunspot down here. We'll look at the polarity of that a little bit later. It looks like it's South Pole leading umbra there, but anyway, here are these new sunspots. Great close-up of those. We've got quite a lot of imagery today, so as there is definitely a lot going on. So there's definitely a lot of predictive value in a lot of the data that we're seeing here. Of course, forecasting things like coronal mass ejections and solar flares are they're sort of cutting edge when it comes to solar forecasting. So there's our GOES proton flux. It's back to flatline now after a significant dual solar energetic particle event, or SEP. So that was exciting. And what's exciting also is our merch shop. So if you've never checked it out, check out the links below the video. You'll find the merch shop down there. Items of various different sort of leanings, if you will. Some of them a little bit inflammatory. Some of them just souvenirs. And congratulations on surviving a global scamdemic so far. Today's featured product is Do the Math, the Sun. So you can get this design on all kinds of things, from bucket hats. I think there's even a clock. So high-res image of the sun there. It's a really high-res image, by the way. It's like 5,000 pixels, the original at least. So if you get it on something big, it will have an incredible amount of detail there. It comes on socks, tote bags, etc. Makes a great gift. So again, check out the links below the video, as we get paid just this side of nothing to put the content on YouTube. So we attempt to make up for it slightly with some merch sales. We've got some new designs just about to come out, like MAXA, which is Make Astronomy Cosmology Science Again, and so on. So make Earth not suck again by picking up some of our merch and help support the channel with some tangible items. We don't just do information. Yeah, we do all kinds of different various things. There's even original music, yes. Check the playlists on the YouTube channel for that. The 12 Days of Smash Mess, a fine example. Anyway, there's the GOES X-ray flux, and we've got a flare going on right now. We're going to take a look at it here momentarily. First, we're going to look at the last 24 hours in 131 angstroms. We're also going to show you 94 angstroms. Actually, that's 94 plus 131 there. So we're showing you both at the same time. How do you like that? Yeah. You're condensed matter, we're condensed matter, and we're condensing a lot of matters of space weather and real science into your video. Isn't that special? So yeah, new sunspots there in the northeast. Here's a close-up of them in those wavelengths. Again, don't be surprised to see a large flare out of the southeastern limb, as well as the northwestern limb. And here's what's going on overhead, just so you know, to orient yourselves. If you're up before dawn, you might see a conjunction of Saturn and Mercury, which may have a lot of people confused. Oh my God, Saturn and Mercury are about to collide. They're right next to each other, right? Well, not so much. They're really far apart. It's just a perspective thing, folks. But you can call it a conjunction. Astrologers think this means something like, the ocean is going to be fast today or something. Some vague, nonsensical stuff about this. But, from a physics perspective, it doesn't mean jack. It's just cool that Saturn and Mercury are so close by in the morning. It's a great way to see Mercury because Saturn is saying, hey, look at me. Look at me. I'm telling you where Mercury is. Anyway, here's your solar system forecast. Here's where things will be in a week. It's a lonely side of the solar system right now. No planets over here except Earth. Anyway, we've got some imagery from the George Mason University coronagraph analysis thingy. It's a great computer program that it will show you halo eruptions often when they occur. We do have a little bit of relativistic particles there striking the aperture. You'll see a bunch of like rectangles forming there. That's an indication of a little minor SEP event on the Soho Lasco. So we don't believe any of those CMEs are earthly directed. Here are today's frames. Those previous frames were yesterday, March 1st. This is today, March 2nd. And we've also got views from Stereo A. So Stereo A located only a few degrees behind Earth, orbitally speaking. And this would show us if there were indeed any Earth-directed CMEs. And I don't believe we're seeing any. Let's just forward this. We do have one there coming out of the south a bit. That was, let's see, yesterday at 1738. And what do we have here? Limited data? What's going on? It didn't like my value. All right, that's fine. So we've got that CME. We're going to analyze that. Give it a minute. There's 1609. All right, so that doesn't look earthly directed. It looks like there are multiple events happening here at the same time. We see some activity in the north also. I don't see anything on the earthly line here, so I don't believe those are any earthly directed CMEs, and if they are, they're very minor ones. They're very diffuse. So no major events there, although there is sort of something major. This filament right here is about to eject. So that's the Brian Keating filament that we named just this morning. Sorry, we didn't give you the opportunity to name that one. And we've actually shown 193 angstroms here in our 24-hour coronagraph images, because the Brian Keating filament is going to eject. That's part of the reason why we named it that, as Brian Keating is one of the cutting-edge people who will help to rewrite cosmology and astrophysics. Yeah, rewrite cosmology and astrophysics. Or at least make some repairs. Let's just say that. It's less inflammatory. Hopefully that didn't offend any of you cosmologists out there. Here we're zooming in a little bit closer. This is 193 angstroms. And once again, this shows the extended corona, and you can see how much of a filament is hanging out there at the southeastern limb. So it doesn't do it justice just looking at the SDO imagery. You see how huge that is. That filament is practically the diameter of the sun itself. That is a gigantic filament, and it's already not looking stable. So as we get closer here, you'll see how that's rotating toward the Earth. It's just a huge filament down there in the southeast. And it will eject. Will it be directed toward Earth? I have no idea. I mean, that's way too chaotic of a process to forecast the trajectory. So let's just move on and look at filaments. And again, that Brian Keating filament, that is legit. Check that thing out. Dag. I mean, this one here is actually a separate one, but there are some that can be named here. So if you want to name the one that's in front of it, that might be a good call. Over here we have the Hillary Clinton and Kamala Harris filaments are still hanging out. I don't remember the names of the rest of these. That's up to you guys. So hit us up on Twitter if you want to name filaments. You know, it's fun to name filaments after living humans. So try that out over on the Twitter feed. And of course, you'll have to join us over there to see all the content, but we do have the Hemp Lucid link. So if you're looking for some free samples for mushroom gummies, we've got those covered. Just click the link that's pinned to our Twitter profile, and you'll find that. And make sure you follow the hashtag #NameThatFilament. All right, so we've got a flare here going on, and indeed it is coming from the southeastern limb. So how's that for a forecast? That happened in real time. So there you go. There's the flare that's occurring right now. And that could be the release of the Brian Keating filament. So, you know, the sun is a thing that it can suddenly change with basically no warning, except our channel. So enjoy that. That's the past about 2.5 hours there from the Go 16 SUVI. That's what we typically stream all day on the Twitch channel at twitch.tv/SmasherMatt. And of course, we would never attempt to pull you away from incredibly great platforms like YouTube and BitChute. So here's the past 24 hours. We've now put together 304 plus 171 angstroms, 2 classic wavelengths there, and it really gives some depth and character to the closest star. You can see filaments, you can see the active regions there and the plasma aligning to the magnetic field lines. Just splentacular imagery. And let's kind of go around the horn here. Here's your northwestern limb. Again, we're showing more imagery than we normally show today because there's so much going on. So that's sort of a conundrum we face every morning, is how much to show, what portions to show. Do we have to show a certain feature and slow it down or something like that? That's sort of a metric that goes on every morning at the Smash News Network, Least Busted Name in News, and there's a close-up of that area, and that is there could be an X-flare coming from that area over there, right? So you never know, and but that's a CME forecast, okay? If anybody else has forecasted CMEs ever, let us know. We were doing it consistently. We did about, I don't know, I think about 14 in a row. Was it about 14 in a row, Smash Staff? We missed 0 of them. We forecasted every CME, and there was, I think, 1 false alarm out of 14 or something like that. So that's a pretty good record last I checked. So there are your new sunspots in the northeastern limb. Filaments, filaments, filaments. Likelihood of CMEs, 99.9%. Point bar means a repeating decimal. So 99.9%. 99.9%. That's the likelihood of coronal mass ejections. There's probably one happening as we create the video. Let's go back to the Go 16 SUVI just for a quick second here. Dag, we've got a lot of tabs open today. We have like 100 tabs open today, folks. So we'll try to survive this video without crashing the PC. And yeah, that is the spot to watch for sure. No major motion of that filament yet, so looks like it's still anchored. Anyway, let's get to our bonus features segment here, as we got to look at satellite charging hazards, as we have significant satellite charging hazards once again. Some internal charging by high energy electrons here around the equatorial southern Indian Ocean, and some surface charging hazards around the equatorial northern Pacific. Goes electron flux here a little on the high side. We got to about, I think it was about 3.7 times warning levels yesterday. There you go, about 3.6 at least. 3.57 times warning level. That's not super high. We've reported as high as 32 times warning levels, which would be way up here above 10 to the 9th. The forecast is for a slight increase here, so expect some additional possibilities with charging hazards for satellites. There is the 1-year chart to put it in context. That's from Solon.info if you want to go follow that yourself. The great solar data source, Solon.info. That electron flux is measured at the F layer of the ionosphere, so let's show the vibrational frequency of that and the anomalygram. So we did show some huge anomalies here just a couple of days ago. They were basically global scale, low frequency anomalies for the most part. And that's likely a result of solar plasma, actually. And in many ways, the ionosphere is the bridge between Earth and space. We do certainly have some significant anomalies here. Let's bring up the latest image and switch to anomalygram. So, of course, the most likely place to see anomalies on the ionosphere maps is right here over the South Atlantic anomaly, which looks like it's right over the middle of the South American continent once again. Yeah, it might be splitting up. I'm not so sure about that. South Atlantic anomaly's been looking funky for a couple of months here, folks. So, I mean, we definitely watched it move because it left the South American continent. I mean, our regular viewers saw that. It was clear in the imagery. Anyway, view our videos from 2 months ago if you if you want to see those anomalies. Our channel provides a nice, convenient catalog of all of this data, so I don't think you can actually access it after it's like a day old or something like that. But in any case, we show it daily, so there might be a tiny gap because sometimes the videos come out at different times a day. But anyway, there's the latest image. That's 12:15 universal time ionogram and 12:15 universal time anomalygram. And that's, by the way, anomaly in megahertz from a 30-day median. You can change that setting if you want to, by the way. You can switch it to anomaly in megahertz, or anomaly in percentage, or difference in megahertz from yesterday. We like to use a 30-day median to show the seasonal changes. Anyway, there's the latest image. Once again, there's the ionogram. That's the raw vibrational frequency, and that's the anomaly in megahertz, which actually does show a little additional resolution, by the way. It goes down to 1/10 of a megahertz instead of just integers, as depicted here. Anyway, switching to the total electron content forecast. It'll show the free electrons between your GPS satellite and your handset. And we are expecting things to be a little bit more organized here, as we typically see with high levels of electron flux. We see more disorganized total electron contents when we see low electron flux, like during coronal hole high-speed streams and coronal mass ejection impacts. And yeah, so that's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Again, it'll show you the most likely places for GPS errors. Let me shrink that down one spot there just so you see the slider bar. We'll let it play through one more time. Don't forget to turn on your Wi-Fi accuracy if you're expecting bad navigation. Don't do a Michael Scott and follow your GPS into a lake. All right, continuing on to our latest imagery here. And of course, it's always exciting to check out brand new sunspots, so let's do that. So there is that's a significant group. It's got a leading North Pole umbra, and then a series of trailing South Pole umbrae, making it a beta gamma class sunspot. This one here. I think that one's beta gamma class too. Oh, maybe not. Nope, just one umbra of North Pole orientation. Let's take a look at this group since it's produced some major flares. Still beta gamma delta class. Once again, as it gets closer to the limits, more likely to produce an X flare. And this group down here is magnetically complex. There we go. That is beta gamma class. Interestingly enough, it has a leading North Pole umbra there. But those are largely aligned. They're largely aligned latitudinally from each other. Anyway, this leading, that might actually be the leading umbra out there. So let's see, is it South Pole? One would expect it to have a South Pole leading umbra. Anyway, that one is magnetically complex. It's certainly beta gamma class. And do we have a new group down here yet? Nope, not yet. Do we see any magnetism rising yet? Not so much. Anyway, here's your full disk. Let's get to our meteorology segment, as this video is getting lengthy and we don't want it to be too long. So first thing we're looking at here is something very scary. I mean, you might be scared and spooked about this. I'm not sure if you're scared and spooked of the infamous carbon dioxide. Yeah, one of the great features of nullschool.net is you can follow carbon dioxide. I mean, you can show all kinds of empirical data, facts, as satellites are able to pick up the emission spectra of said carbon dioxide. And Look at South America. Look at the disparity. Oh my God, what is going on here? It's only 405 parts per million there, but up here, it's 438 parts per million. So, I mean, it's probably a huge heat wave up there. But anyway, you can also look at things like temperature, right? So all kinds of features of nullschool.net that you may not be aware of. Nullschool.net. We show it daily on the channel because it's just splentacular. And there is the temperature at the surface level. Now, of course, since Earth is croissant-shaped, we try not to show the poles too much because they're pointy and curved in a real weird way because the Earth is shaped like a croissant. Oh, that's the other merch we have to make. Croissant Earth. Yeah, I've got to make that. That's going to be hard. I'm going to have to take NASA's imagery of the map projected onto a fake sphere and project it onto a fake, real croissant, because that's the way it goes. All right, so let's look at the surface winds here and get through this video so we can get it onto your screens. And press that share button to get it onto more people's screens. A bunch of strong lows here around the, American Samoa, somewhere around there. Tonga, Fiji, and so on. A couple of lows there. Those are the surface winds. Here are the jet streams. Let's get around the planet. Jet streams of the east. Jet streams of the west. Surface winds of the west. Multiple strong lows in the North Atlantic. It's a bad day to be on a boat with Marky Mark and George Clooney. A lot of big waves in the North Atlantic. Surface winds of the central world looking like this, and these are the jet streams. Your weather.gov map is coming up. In the meantime, don't forget to visit the links below the video, like smashomash.com, the official homepage of the Smash News Network, least busted name in news. And welcome to the Neo-Renaissance. We didn't forget the tagline. We just removed it from the homepage because of search, because of AI and all that other nonsense that makes us do things that we frankly don't want to do. Smashomash.com. Find our links there. You can also find a link to the Hemp Lucid shop. Don't forget to enter the promo code SMASHOMASH to save some cash. SMASHOMASH to save some cash on checkout at hemplucid.com. You can also use our personal link. They are the most popular, like the water-soluble CBD tinctures. Lots of other solutions there, like body butter and lip balm and all kinds of awesome products. And let's take a look at the visible satellite for once. So there's the visible satellite rising over Croissant Earth, which looks oddly spherical on NASA's data here. I don't know what's going on. How could this be, folks? Let's get some more recent imagery here, since it took us quite a while to do show prep today. The planet will be even brighter as we've got some additional frames. There you go. There is the fantastic sunrise over the Western world as spring approaches. You can see those systems there in the North Atlantic with their counterclockwise rotation. And let's move on to our weather.gov map. So there you go. There are your weather warnings for the U.S., the entire 50 states of AUSA, the allegedly United States of America. And here is the key. If your location's lit, click your location. We can't go over that. It looks like there's some winter storm warnings in Hawaii on Mauna Loa and Mauna Kea. All right, so we just wanted to familiarize our viewers here briefly with isotherms. These lines are called isotherms, and this is a 72-hour GFS temperature forecast. What it's showing you there is the purple line is where the freezing point is located, and the blue is below freezing, and red is above freezing. And it also shows you the wind. So those little F's, those are the wind speed and direction. So the number of flags is the speed, and the direction is the way it would be blowing, obviously. It would be coming from the post. Anyway, That gives you a lot of information that might not be visible in a regular shaded temperature map. I mean, that might not work for some of you. Let us know in the comments what you think of the isotherm temperature forecast. That might only appeal to meteorologist nerds. I'm not sure on that one. Anyway, continuing on here to our temperature anomaly forecast. This is the same model, the 72-hour GFS 72-hour GFS temperature anomaly forecast there. That's in degrees Celsius. The last one was in degrees Fahrenheit, so keep that in mind. We've also got the shaded temperatures there. That's the raw temperature forecast for the same model, the 72-hour GFS. And we've also got the pressure and precipitation forecast, as there are some heavy storms that are going to bring ice to the states of mainly Pennsylvania and New York. Pennsylvania and New York are going to get plastered with ice, also New England. So there's going to be a strong low that develops over Arkansas right here. And then kapow, it's going to produce some major storms there. You're going to see some strong storms that can produce things like damaging wind and hail and so forth over places like southeastern Missouri, southern Illinois, most of Indiana, Ohio. And then it's all going to turn to ice. Pennsylvania is going to get kaplastered. So be prepared for power outages, as, you know, spring ice storms have a tendency to bring down trees and hence power lines and so forth. You can even get accumulation directly on the power lines and things. So be ready for that, and be ready for some strong storms here coming to Texas, Oklahoma, Arkansas, etc. That's a 72-hour GFS pressure and precipitation forecast. Here's your precipitation type, as we've got some ice happening there in New York, Vermont, and New Hampshire. Also Connecticut seeing some ice, or maybe just some wintry mix. Nope, it's showing up as freezing rain. So that is suboptimal for the morning commute, to say the least. South of that, mostly rain. Let's move on here to close this video out. There's your lightning mapper. Some heavy lightning storms there in Texas and the southeastern part of the U.S. We did have some terrestrial strikes. Let's see if there's thunder rolling in anywhere. Indeed, we have some activity there in, what's that? Mississippi. Tupelo. There's thunder rolling into Tupelo. By the time you see this video, there might not be thunder rolling into Tupelo, as it was originally streamed live to twitch.tv/smashomash. Look for more live streams coming to YouTube sometime soon, by the way. What? You talking to me? Could you not talk to me during the live stream? Thanks. There's the full globe map. Smash staff just uttered something under her breath that I couldn't hear. Not appreciated. And here is our U.S. Doppler. All right, so there's a U.S. Doppler. And here is the lower 48 view. It looks like it's going to dry up for a little while here in Pennsylvania. Here is your clouds and fog view. That's 3.9 nanometer infrared radiation from the NASA GOES Interactive Weather Satellite Suite. And there's the water vapor map. Check it out. Some dry air here moving around, colliding with more dry air. It's a dry air collision. Check it out, folks. It's a high pressure colliding with a high pressure. And guess what that causes? Does it cause static electricity to build up and cause people to become psychic? No. It causes the sky to be clear. Yeah, that's the effect. High pressure. It's associated with clear skies. All right, so here's your recap. U.S. Doppler radar, the clouds and fog view, and the water vapor map. Hopefully that sums up some data. I think we've fit quite a bit into the daily space weather video. Thanks for tuning in. We'll see you soon. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.